This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Welcome to the discussion. Today we're delving into a research paper exploring the automation of literature reviews using natural language processing, NLP, and large language models, LLMs. The authors propose and compare multiple approaches focusing on efficiency and accuracy. Let's start with the core problem: why automate literature reviews?
The sheer volume of research publications makes manual literature reviews incredibly time-consuming and prone to human error. Researchers spend countless hours sifting through papers, potentially missing relevant studies or introducing bias. Automation offers a solution to streamline this process, allowing researchers to focus on higher-level analysis and interpretation.
The paper outlines three distinct approaches: frequency-based, using Spacey; transformer-based, using Simple T5; and LLM-based, using GPT 3.5 Turbo. What are the key differences in their methodologies?
The frequency-based approach uses Spacey to identify the most frequent words and sentences in a text, assuming that higher frequency correlates with importance. This is a simpler, less computationally intensive method, but may miss nuanced information. The transformer-based approach leverages the Simple T5 model, a powerful sequence-to-sequence model trained on a large corpus of text, to generate summaries. This approach captures more contextual information. Finally, the LLM-based approach uses GPT 3.5 Turbo with Retrieval Augmented Generation, RAG, allowing the model to access and process a knowledge base, the SciTLDR dataset in this case, to generate more comprehensive and contextually relevant summaries.
The SciTLDR dataset is crucial here. Can you elaborate on its role and why it was chosen?
The SciTLDR dataset contains summaries of scientific documents, including both author-written and expert-derived TLDRs. It provides a benchmark for evaluating the performance of the different automated literature review generation methods. The availability of both the source text, abstract, introduction, conclusion, and the target summaries allows for a robust evaluation using Rouge scores. Speaking of evaluation, how did the authors assess the performance of each approach?
The authors used Rouge scores, a standard metric for evaluating the quality of machine-generated summaries. They calculated Rouge 1, Rouge 2, Rouge L, and Rouge Lassume scores for each approach, comparing the generated summaries to the human-written summaries in the SciTLDR dataset. Higher Rouge scores indicate better agreement between the generated and reference summaries.
And what were the key findings of the comparative analysis? Which approach performed best?
The LLM-based approach using GPT 3.5 Turbo achieved the highest Rouge 1 score, 0.364, significantly outperforming both the Spacey 0.257 and Simple T5 0.268 models. This suggests that LLMs, with their ability to understand context and generate coherent text, are currently the most effective approach for automated literature review generation. However, the transformer-based model also showed promising results.
The paper mentioned the development of a graphical user interface, GUI, for the best performing system. What are the key features and functionalities of this tool? The GUI allows users to upload multiple PDF files, and the system automatically generates a literature review segment using the GPT 3.5 Turbo model. It provides feedback on the progress and indicates completion. While the current version is relatively basic, it demonstrates the potential for creating user-friendly tools for automated literature review generation.
What are some of the limitations of the current approaches, and what are the potential avenues for future research?
One limitation is the reliance on a specific dataset for training and evaluation. The performance of the models might vary across different domains and datasets. Future research could focus on improving the robustness and generalizability of the models, exploring different LLM architectures, and incorporating more sophisticated techniques for knowledge retrieval and synthesis. Furthermore, addressing potential biases in the training data and ensuring the ethical implications of automated literature review generation are crucial.
The paper also reviewed existing literature on automated literature review generation. What were some of the key insights from this review?
The literature review highlighted the ongoing efforts to automate various stages of the systematic literature review process, from searching and screening to synthesis. Many existing tools focus on specific aspects of the process, while this research aims to provide a complete end-to-end pipeline. The review also emphasized the challenges in achieving high-quality synthesis and the need for human oversight, even with advanced automation techniques.
The authors highlight the potential for bias in automated systems. How might this manifest, and how can it be mitigated?
Bias can arise from several sources, including biases in the training data, the algorithms themselves, and the way the system is designed and used. For example, if the training data predominantly features research from a specific geographic region or demographic group, the generated literature review might underrepresent other perspectives. Mitigation strategies include using diverse and representative training data, carefully evaluating the models for bias, and incorporating human in the loop mechanisms to review and correct potential biases.
Beyond bias, what other ethical considerations should be addressed in the development and deployment of automated literature review tools?
Transparency and explainability are crucial. Users should understand how the system works and the limitations of its output. Intellectual property rights and proper attribution of sources are also important considerations. Furthermore, the potential displacement of human researchers and the need for responsible innovation should be carefully considered.
The paper focuses on generating the literature review section of a research paper. Could these techniques be extended to other sections or even to generate entire papers?
While the current focus is on the literature review section, the underlying techniques could potentially be adapted to other sections, such as the introduction or discussion. Generating entire papers automatically is a more ambitious goal, requiring significant advancements in natural language generation and understanding. However, the progress made in this research provides a foundation for future exploration in this direction.
The authors used GPT 3.5 Turbo. How might the use of more recent, larger language models impact the results?
More recent LLMs, with their increased size and training data, often exhibit improved performance in various NLP tasks, including summarization and text generation. Using these models could potentially lead to even higher Rouge scores and more coherent literature reviews. However, it's important to note that simply using a larger model doesn't guarantee better results. Careful fine-tuning and prompt engineering are still crucial.
What are some of the practical implications of this research for researchers and the broader scientific community?
This research offers a significant step towards streamlining the literature review process, saving researchers valuable time and resources. It can improve the efficiency and accuracy of research, potentially leading to faster progress in various scientific fields. However, it's important to remember that these tools are meant to assist researchers, not replace them. Human expertise and critical thinking remain essential for interpreting research findings and drawing meaningful conclusions.
The paper highlights the use of both extractive and abstractive summarization techniques implicitly. Can you elaborate on the differences and their suitability for this task?
Extractive summarization selects sentences directly from the source text, while abstractive summarization generates new sentences that capture the essence of the source text. The frequency-based approach is primarily extractive, while the transformer and LLM-based approaches incorporate elements of both. Abstractive summarization is generally preferred for literature reviews, as it allows for a more concise and coherent summary, but it also requires more sophisticated models.
The paper focuses on PDF files as input. What are the challenges in processing PDFs compared to other text formats, and how are these addressed?
PDFs can present challenges due to their varied formatting and potential for including non-textual elements like images and tables. The authors used libraries like PyPDF2 and regular expressions to extract the textual content from the PDFs, handling variations in formatting. However, accurately extracting information from complex or poorly formatted PDFs remains a challenge.
The authors mention prompt engineering for the LLM-based approach. Can you elaborate on its importance and how it was implemented in this study?
Prompt engineering is crucial for guiding the LLM to generate the desired output. The authors carefully crafted the prompt to specify the desired format, length, and style of the literature review. They also provided the LLM with context from the SciTLDR dataset, allowing it to generate more relevant and coherent summaries. Effective prompt engineering can significantly improve the quality of the LLM's output.
The paper mentions post-processing steps. What types of post-processing were used and why are they necessary?
Post-processing steps were used to refine the generated summaries, ensuring coherence and readability. This might include removing redundant sentences, correcting grammatical errors, and ensuring a consistent writing style. Post-processing is often necessary because the initial output of the models might not be perfectly polished or coherent.
The study uses a relatively small dataset for training and evaluation. How might this affect the generalizability of the findings?
Using a smaller dataset can limit the generalizability of the findings. The models might perform well on the specific dataset used for training and evaluation, but might not generalize well to other datasets or domains. Larger and more diverse datasets are needed to improve the robustness and generalizability of the models.
The paper concludes by suggesting several avenues for future research. What are some of the most promising directions?
Exploring more advanced LLM architectures, incorporating multimodal information, JCE incorporating figures and tables from the PDFs, and developing more sophisticated methods for knowledge retrieval and synthesis are all promising directions. Furthermore, research on addressing bias, ensuring transparency, and considering the ethical implications of automated literature review tools is crucial.
This has been a comprehensive discussion on automating literature reviews. Thank you.